Hello guys, very good morning. Welcome back and let's start. So in the last session we discussed about the Docker installation on Windows laptop. Okay, so how Docker desktop can be created and what is meant by container, what is meant by virtualization. These are the concepts that we have seen in the last session. In this session, we are going to understand about the Docker architecture, and then we are going to check out the configuration related to uh, Docker lifecycle. Okay, Docker architecture and Docker lifecycle, and if possible, I will cover the Docker networking. So this is the last and final session of your demos. This is the third demo which I am presenting you, and from next day, whenever we meet from next day onwards, it will be a paid session. Okay, so those who has paid the fees, they can join the session. Okay. Anyways, coming back to the point here, let us deploy an Docker server. Docker. I will go with Ubuntu operating system. Okay, 2404 is enough. Or if you want to take any another OS, you can select that OS image 2204, 2404. It's your wish. I'm going for 2404 T2 micro, and key pair will be app key. And here I'm going to select an existing security group and default one. This is how you are going to deploy an instance in the AWS. So once I have deployed the instance in AWS, let us access that instance. As of now, this is not required for me. Okay, let me log into the Docker instance now. So cd downloads. I have the key file here, ssh-i app.t.m, and it's an Ubuntu provide the IP address over here so that you can log in into the server. Okay, so sudo su hyphen. Right now, I don't have anything installed on this utilities. Any utilities are installed on this server. So I'm updating the repositories and installing net tools. I will tell you why I have to install this net tools. Without net tools, you cannot see the IP address of your server. How many adapters are there on your server? For that reason, I am installing net tools. Okay. So hold on a second. Now, after installing this, we need to install the Docker on the Ubuntu machine. There are multiple ways that you can install the Docker on this Ubuntu machine. I am going with a simple way, or else you can install Docker in the another way also. So if you see here, if config. Okay, so right now I am having two adapters. Okay, so currently what I have done, I just installed a server. Okay, I just install a server or EC2 instance. Now this EC2 instance will be having a network adapter to communicate with Ethernet. Okay, internet for communicating internet, or else if any user wants to communicate with this server, then it should have a network adapter, and this network adapter is connected to the internet. Okay, so like this. Now, this Ethernet network adapter, whatever the Ethernet adapter that you are seeing, that is this ENX0. Okay, so if any data that needs to come in into the server, and as well as it should go out of the server, that will be happen through this ENX0. Okay, so it is having an IP address. What is the IP address of the server? It is the private IP, that is 10.1.1.159 is the private IP address of the server. Okay. Now, what is the public IP address of the server? The public IP address of the server is, this is the public IP address of the server. So from the internet, if anybody wants to communicate, they will communicate with the public IP. Okay, if any data that should be entered into the server, that will happen through this public IP. Now, if there is another server in the same network, if it has to communicate with this server, it will happen through the private IP. Okay. So now there is a network adapter. This is the first network adapter which I am showing you right now. And there is LO. LO means loopback adapter. It is for the testing purpose. So this loopback adapter will be inbuilt and it will be there in each and every device. So in my computer also I will be having a loopback adapter. So that is see here 127.0.0.1. This is the IP address of the loopback adapter. Again, I don't need to show you about that. So there is another adapter called as loopback adapter inside the computer to test the network. Okay, within the computer, if you want to test whether the networking is properly happening or not, or else adapter is properly working or not, functionality is there or not. For that purpose, you can go with the 127.0.0.1. Some cases for the website also, if you deploy any website in your system, to access that website also, you will be using loopback address only. Okay, especially simply if I have to phrase that, loopback adapter is helpful for you to make the communication or else to make the testing within the system for any testing purpose. Okay. Now I will try to install the Docker. If you see here right now, we are having two adapters. Now let us install Docker. curl-sl https://get.docker.com and bash. This command will install the Docker. So what is this get.docker.com? Here you will have the entire bash script or shell script which will be installing the Docker. See that? This is the Docker engine installation steps which we are going ahead, and the version is 23.0.0. So now this particular command will run the shell script. Okay, see here. Okay, so the Docker is getting installed. Once the Docker is installed, later what we are going to do here is we will check how many network adapters are there. So hold on. So yeah, so this is about the Docker. Now we have installed the Docker software in our system. Okay, in my computer or in my server. Okay, now the point is what happens after installing the Docker. For example, this is the Docker which I have installed or which you will install in your system. Now, by defaultly, there will be a network adapter that is going to be created. If you see here, the Docker installation is completed. Now, what you need to check here, let us see if config. So previously, we are having these two network adapters. When we install the Docker, automatically one bridge adapter has been created. So that is Docker 0, which is a bridge adapter that will be a primary point of contact between the containers and the outside world. So now here what happened, a new adapter is created. That is Docker 0 adapter is created. And this Docker 0 adapter will be connecting towards the external server adapter. Okay, so whatever the server adapter that we are having, this Docker bridge adapter will be connecting to that server adapter. Now, if I create any container inside the Docker, if I create any container inside the Docker, this container will communicate with this bridge adapter. And from the bridge adapter, the communication will start flowing into the Ethernet network adapter. So here, if you see, this is the container one. Container one. Okay, so this container by default, now the bridge adapter, whatever you are seeing here, what is the name of this adapter? This is Docker 0. This bridge adapter by defaultly in the network 172.17.0.0/16. So this is the network range of this particular adapter. So whatever the containers that are creating under this bridge network adapter, under Docker 0 bridge network adapter, they are going to get the same range of IP address 172.17.0.2. Okay, and here why 0.2, where is 0.1 means this Docker 0 adapter will have 172.17.0.1. It's a gateway. 172.17.0.1. Now, what is meant by gateway? See, if all the containers are there, so there will be another container creating. Okay, so if the container is creating under this bridge network adapter, now there should be, if these containers wants to communicate with the internet. So the container one wants to communicate with the internet. And there is one more container, that is container two. Container, if I am creating another container called as container two, and it is also having the IP address 172.17.0.3. This is the IP address of the container. Now, if all these containers has to communicate with the internet, if they want to get some data from the internet, how they are going to get? First of all, the request will be going to this Docker bridge network adapter. Here you have to understand, if anything passing through an adapter, then that is called as a gateway. So for all these containers, the gateway is the bridge network adapter. So for all the containers, if you see in an office, if you are in the office, or else in your home also, if you are having a router, so the router IP address will become as a gateway. Why? Because all the systems and phones, whatever you are using, if they want to communicate with the internet, they have to leave the first stage. They have to leave your home router first. Okay, so if the data has to leave the home router, so that home router will become as a gateway. Here also, the Docker Zero Bridge Network Adapter is the gateway for the data to be transferred from the container to the internet and as well as from the internet to the container. So that is why the gateway should have an IP address that is 172.17.0.1, and remaining containers will have the IP address 172.17.0.2. Okay, 0.2, 0.3 like that. Okay. So now let us create a container first. So first of all, let us see how many network adapters are there irrespective, like respective to the Docker. Docker network ls. Very important. Write down the commands to check the number of network adapters that you are having. The command which we are using here is Docker network ls. So if you give this command, it is going to display all of the network adapters that are present in the Docker. So this is the bridge network adapter which has been recently created. And this is the host adapter. Host adapter is nothing but host is our server only, where we have hosted the Docker. The Docker is hosted on the server, and the host means host adapter means nothing but your Ethernet adapter. And none or null. This is nothing but the loopback adapter. So these are the three adapters which has been present. Okay. So if you want to create any network adapter, you can create it. But before we go into that, let us inspect this bridge network adapter. I said, whenever the network adapter is created, it will be creating in the range called as 172.17.0.6, 16. Let us see whether it is created or not. For that, Docker inspect, Docker inspect network, or else, sorry, my fault. Docker network inspect. Oh, there's a problem with this. 1 second, yes. I think there is a small network issue. Okay, hold on. Docker network inspect. And what is the network name? The network name is bridge network. So whatever the network you are seeing here, that is a bridge network. You have to give that name, bridge. So now if you see here, so there is a bridge network and this is the ID when it was created. And then if you go down, you can see here, what is the gateway? 172.17.0.1 is the gateway and subnet is 172.17.0.0/16. I already said you that the adapter, the bridge adapter will act like a gateway. Now, are any containers that are attached in this particular networking device? I mean, under this networking device, no containers are there. Right now, we did not create any container. So the default network adapter for a Docker is Docker bridge network adapter. So now what I will do, I will try to create a container. Docker run hyphen itd hyphen name test container. Okay, and the image is Ubuntu. Okay, so remember this. This is very important. Unable to find the image. Right now, the container got created to check the container running status. Try to know, write it down. It's very important. Each and every command is very important. So to check whether the container is running or not, for that, what we are going to do, docker ps. So it is going to show you whichever the containers that are running right now. So it is saying the status is up 17 seconds, which means that the container is running. So what is the container name? Test container. There is one more command called as docker ps-a. So this command will show you whatever the containers that are running, that are stopped, every container it is going to show you. So docker ps or docker ps-a, both the commands you can use. So the first command will help you to show you whatever the containers that are running, only running containers will be displayed. And docker ps-a will show you all the containers, so whether the containers are running or not running or stopped or exited, shut down, any state, any state of the containers can be shown with the command docker ps-a. Right. Now the next one is, now if you see here, Docker network ls, we are having three network adapters. Previously, if you see, there are no containers running. Now what I will do here is, again, I will go with the Docker network inspect bridge. Now, if you see, there is a container created, and what is the name of the container? Test container, and this is the ID of the container. Previously, if you see this containers field, it is empty. Now it is having a test container, and this test container is having the IP address 172.17.0.2. As I already said you, 172.17.0.2. And now, if I create another container, so let me create another container. By default, I am not assigning any network. So Docker run hyphen itd, the name of the container is test container 2. Okay, so here we have created the test container 2. Now if you can see docker inspect bridge, there are two containers. One is test container, which is having 172.17.0.2, and the other one is test container 2, 172.17.0.3. So these are the two containers which are created under the bridge network, default bridge network adapter. Now let us log in into each of the container. Now I will log in into each of the container. How I can log in? Docker execute hyphen it test container and bash. When you give this command, you will be logging into the container. Right now, this container doesn't have any sort of utilities. So if you go for if config, no utility is there. Ping, not found. So these small utilities also not going to be present inside your container. Why? Because the size of the image is only 78 MB. The environment, whichever you are seeing, the Ubuntu environment, whichever you are seeing, that is only 78 MB only. So for that reason, it doesn't have any utilities. Only the basic utilities are also not available inside the container. We have to install it. apt update -y and apt install -y net-tools and then ip utils-ping. So when I install this, good. So now ping and now if you see if config, it will work. So this is the IP address of your container. Okay, this is the IP address of your container. We are currently in 172.17.0.2, which means we are in the first container. Let us try to ping to the second container. Ping 172.17.0.3. 0.3 is the IP address of the second container, test container 2. So we are getting the response, which means that what did you understand from this? Whatever the containers that are created under the same network adapter, they will communicate with each other. So the test container 1 will communicate with the test container 2. Okay. So in some cases, when we are running the containers, we have to make sure that the containers are pinging, or else the containers are getting the response through the name. Okay, through the name, they have to get the response. One container has to communicate with the another container through the name. Why it is required? Why it is required? For example, I am having a front end container. I am having a front end container, which means UI container, and then I am having a back end container, like database container or any MySQL or PostgreSQL container is there. Now, actually, databases will not be created inside the container, but just to make you understand, I'm creating this. Now, these two containers should be in interaction. These two containers should be in the connection. Why? Because if any data that is given by the user, the data will be collected by the front end container and it will be forwarded to the back end container. Now, these two should have a communication. For example, the container one is having the IP address 172.21.0.1 and the database container is having 172.21.0.2. So these are the two IP addresses which are having for the two containers. Now suddenly containers are, I cannot say you the containers are stateless objects. What is stateless object? At any given trigger point, I cannot say the container will be continuously running, but at any given point, sometimes the containers will shut down. The containers will be deleted. So for that reason, what I will do here is, if this container is deleted, if the container is deleted, now the IP address will be free. The IP address will be free. Now what happens when any new container is created at the same time? When any new container is created at the same time, then the IP address, whatever the IP address of the previous container will be assigned to the new container. And whenever we are creating the new container back, the front end container back, we have to start the container back. Then it will have a different IP address. Then it will have 172.21.0.4. This is the different IP address that will be present for the front end container now. Previously, it is 172.21.0.1. Now it is 172.21.0.4, which means that we have to change the entire configuration for making the communication happen between these two containers. So in this case, I cannot give the IP address in the application. If I give the IP address in the application, then what happens? I don't know. The container might be deleted. So the IP address, whatever the new IP address is there, that will be assigned to the container. So what I have to do? Now, before I go into that concept, now can you tell me what did you understand from the entire theory which we have seen now, which I gave as a lecture to you? Can you tell me what did you understand from the entire concept from the beginning or from now? Anyways, at least if you say a phrase of words, that would be good. So what did you understand?
Containers are stateless.
Okay. Containers are stateless. Later.
So you cannot use the IP address for the
Okay.
communication between.
So I cannot use the IP address for the communication between the two containers. Then what I have to use? So I cannot use the IP address, but instead of that, I can use the name. For example, this is my front end. So this is the name of the container, and this is my backend container. So now, if these two containers are communicating with the names, if these two containers are communicating with the names, then we don't need the IP address. IP address in the sense backend name resolution will happen. Again, coming to the point, name resolution will happen. For example, how we are communicating with the internet. So if I want any website, for example, what you will do, you will type www.google.com. Okay, but back end what happens? That is the naming convention which we will understand. But computers only understand computers or containers, any what I can say, logical device or physical device, they will understand only the IP address. So if happens, ns lookup google.com. So now what happens whenever I give google.com, it will go with to this IP address only, which means that in the back end, the name resolution will happen, which means that converting the name into the IP address. So If this IP address is deleted, also no problem. A new IP address will be assigned to the container, but the front end, the name of the container is the same. So the container, if the container name is same and in the back end, whatever the IP address is changing, it doesn't matter. Okay. So these two containers should communicate with the name. But in default network adapter, that will not happen. In the default network adapter, that will not happen. What happens here is, hold on. So hold on. What happens here is, let me log on to one of the container, Docker PS. We have test container and test container 2. Now let me log on to test container 1. Docker execute -it test container and bash. Now I just logged into the first container. If I try to ping with the name test container 2, see, I'm not getting any sort of response. So what is the meaning of this? The meaning is, but they will communicate with the IP address 172.17.0.3. Okay, so from the test container 1 to test container 2, through the IP, we are able to communicate, but with the name, we are unable to communicate. So the point, the final thing here is, in the default network adapter, the conclusion is, the default network adapter, whatever the containers that are created, these containers will not communicate with the names. They will only communicate with the IP addresses. Now, then what we have to do? So we have to create a new network adapter. So new Docker network adapter. So that is called as an external network adapter, which we are creating. It is also a bridge network adapter. We are creating this network adapter manually. We are creating, so whatever the Docker 0 or whatever you see, this bridge network adapter, it is created automatically by the Docker. Now whatever the new network adapter that we are creating, it's a manual network adapter, or we can call it as a external network adapter. Now after creating this network adapter, we are connecting these two containers so that they will communicate with the name also. Let us see first of all how to create this network adapter. So I will come out of the container, exit, or else you can press Control PQ also. Control PQ. So you will be coming out of the container. Control PQ or exit. Any command that you can use. Control PQ is the buttons which you have to press, or you can give the command exit. Now we just came out of the container. So now if you see how many network adapters are there. If you see Docker network LS, we have only 3 network adapters, and among those, this bridge network adapter is the Docker network adapter. Let us create a new adapter. Docker network create test network testnet. This is the name of the network which I am creating. So if you see, a new network has been created. If you can see Docker network LS, see that previously we are having only 3 network adapters. Right now, a new network adapter has been created. What is the new network adapter? That is testnet. Just now we have created. No, it is also a type of bridge network adapter only. So whenever you see the bridge network adapter, it is an interface between the Docker containers to your external network adapter of the server. Okay, fine. So now what we have to do? Whatever the Docker network inspect bridge. So whatever the network adapters, so I'm inspecting this particular default network adapter, and whatever the containers that are there in this bridge network adapter, I have to remove them and I have to assign it to the new network adapter that we have created. So if you can see, here we are having 2 containers, container 1 and container 2. Now what I will do, I will remove the containers from the bridge network adapter and I will connect it to the external network adapter which we have created. So Docker network disconnect bridge test container and then test container 2. So if you inspect the default bridge network adapter, it doesn't have any containers now. Okay, it doesn't have any containers now. That means the containers will not be connected to the new network adapter. Okay, automatically they will not connect. So if you see Docker network inspect testnet. So this is also one of the network which we have just recently created. Now, if you see here also the containers are not connected, which means that the containers are not there on the default network as well as on the new network which we have created. Okay, so they are in some state. So now if you see Docker execute -it test container and bash. Okay. Now what I will do here is, now let me connect these two containers to the new network adapter. So how I can connect Docker network, sorry, uh, yeah, Docker network connect testnet test container. I am connecting test container and then test container 2. So two containers I have connected to the new network adapter. If you can see here, so two containers are connected and the test container is having the IP address 172.18.0.2 and new container, test container 2 is having the IP address 172.18.0.3. Now, which means that these two containers are connected to the new adapter and which is having the IP address 172.18.0.2 and it is having the IP address 172.18.0.3. So these two containers are having the new IP address, which means that they are disconnected from the bridge network adapter. They are disconnected from the bridge network adapter and they are connected to the new external network adapter which we have created. Now let us log in into one of the container and ping to the another container. So I just logged into the test container and I am pinging test container 2. Ping test container 2. Now I'm getting the response from the test container 2 also. So what is the final conclusion that we can give, summary we can give here is, whenever you are having the containers under the default network adapter, they will not communicate with the name. So they will communicate with the IP address only. If you have created a new network and within that network, if you want to make the communication between the containers through the name, it will communicate. So this is the final verdict. Understood about this networking concept? Any questions here?
Chaitanya, I have one
Mhm,
question. If you
mhm.
restart that container, like a test container 2, and if I try to ping using the name, then it will get communicated, correct?
Yes.
With that. So can you do that? Like that, I want to see.
What? Come again?
I want to stop and start container 2, and then I need to ping to the test
Mm.
one, container one. Is it
You
will
test
not?
it now? You test it now. So if you stop the container, Docker stop test the container 2. This is what you requested for.
Yeah, yeah.
I have stopped it.
Hmm.
Then what is your requirement?
Again, restart and then check ping. So after restarting, IP address will get changed.
No,
No,
it will
that is
not
what.
change. It will not change. Now it is not going to be changed. Why? Because see here, we have only two containers. Either you will have 2 and 3. If you are having more containers, then the IP address will change. Now let me show you that. Docker start. I'm stopping the container. Docker stop test container test container 2. Okay, I have stopped the test container and started the test container. Let me log on to my first container. That is test container 1. Okay. Now if you ping test container 2, you are getting the response from test container 2. See here 172.18.0.3 only. Okay, if you create or else let me do one. So to make you more understandable, I will exit. Okay, so I'm
Hmm.
exiting the test container 1. Now what I will do here is Docker stop test container 2. So when I stop it, the IP address will be released. 172.18.0.3 will be released. That is the IP address of test container 2, right?
Correct.
Okay, hold on a second. Docker run -itd -name test container 3. Okay, and -network test net. I am creating this container test container 3 under test network. Okay, and with the image Ubuntu. Okay, so now if you see Docker PS, we have two containers. One is test container 1 and test container 3, which are in running state. So if I give Docker PS -a, there are three containers. One is test container 2, and test container 3. Test container 2 is in now stopped state. Am I clear here?
Correct. Yeah.
Okay, now let us inspect the network. Docker network inspect test net. If you inspect this, to which container 172.18.0.3 is assigned? It is
Correct.
assigned to test container 3. Am I clear here? Now,
Yeah.
if I start docker start test container 2, if I start this, what is the IP address that is going to be assigned? See here,
Four.
for test container 2, it is assigned with 172.18.0.4. So up to now, it is clear, right? Now, let me go to the, I will be logging into my first container, test container, and now I will ping to test container 2. Am I getting the response from
Yeah.
0.4?
Correct.
Okay,
Correct.
irrespective of your IP address, if you are communicating with the name, you will be getting the response. Is it clear?
Yeah.
Yeah. So this is how the Docker networking will help you. And whenever I say you an example, small application, if I say you with a small application, then you will understand very clearly. Within 2 to 3 days, you will understand that. But as of now, this is about your entire Docker networking. I hope you understand. So the Docker network adapters are of multiple types. One is bridge network adapter, overlay network adapter, ingress network adapter. These overlay and ingress will be coming in the Docker swarm. Whenever I am discussing about the Docker swarm, there I will tell you what is meant by overlay and what is meant by ingress. So, but basically, now you need to understand only the bridge network adapter. That's more than enough. Whatever the two adapters, the default bridge adapter and new bridge adapter, which is created by the user. Okay. Any questions here? Any questions?
No, only two, right? Bridge network adapter and custom network adapter that you create.
Yes.
Oh, okay.
Only two network adapter. If you see this diagram, you will understand. This is the bridge network adapter, which is created defaultly by Docker. And this is the network adapter which I have created. You can create your own network adapters like overlay network adapter or ingress network adapter also, but those will not be used in the single Docker component. When you go for the Docker swarm in the orchestration format, then you can use the overlay and ingress controller, not here,
Okay.
right? So
Yeah.
so this is about your entire Docker architecture. Okay. Now let me tell you one thing. So this is whatever you are seeing here. This is my Linux server. This is my Linux server. So now what I will do here is let me go for watch -n1 ls-la. It will communicate like it will. Now I will go into my Windows system. Right now I am into the Windows system. See users, Chaitu and downloads, whichever you are seeing. This is my Windows system. And if you can see here, whatever the root at the rate 10.11.159, this is my AWS EC2 Windows Ubuntu operating system or else Ubuntu server. So I am not touching my Ubuntu server. Let us see one thing, that is Docker architecture. Both the ways I will show you. Docker architecture, how Docker architecture will be there. So whenever, if any user wants to communicate with the Docker application, he wants something, he want to create a container, he want to log in into the container. He wants to stop the container, he wants to start the container, he wants to restart the container, if he wants to make any modifications of the container, he wants to create a Docker image, Docker volume, Docker network, anything, if anything that should that a user wants to do with the Docker, first of all, he has to interact with the Docker CLI. Now, whatever you are seeing here, this is the Docker CLI. So where the user will interact with the Docker by using the Docker commands. So everywhere we will use Docker start, okay, Docker run, Docker network. So at any given point of time, the first word will be the Docker only, which means that, so it's a Docker CLI. So now the user is communicating with the Docker CLI. So here, let me do one thing. On my Windows operating system, Docker PS. See here, when I go for Docker PS, I am not getting any sort of response. Why? Because the Docker daemon is not running. So first of all, I need to start the Docker daemon, which is Docker desktop for my Windows operating system. I'm starting the Docker desktop. In the same manner, let the Docker desktop come. In the same manner, in the Ubuntu operating system also, you will do the same. So if you see here, the Docker desktop, it is starting the Docker engine. Once the Docker engine is started, now if you give the same command, you are getting the response. You are getting the response Docker PS, it is giving the response, which means that there should be a Docker daemon to provide you the response from the Docker. So this is the Docker daemon. Okay, good. Now what this Docker daemon will do? So if you don't have the Docker daemon, then you will not be able to communicate with the Docker applications. So this is the Docker daemon. Okay, so hold on. Docker and daemon. Now what I will do here is whenever I give any command, right now here you can see there is containers, there are images. Okay, there are images and as well as there are the containers. So if I show you, there are certain containers which are not running. Okay, here you can see the containers that are not running. So if I pass any command, like Docker PS or Docker images, Docker PS or else Docker PS -a. So now my command will go to the Docker daemon. Now my request will go to the Docker daemon from the Docker CLI. And what is the request? Docker PS-a, which means that it will request the Docker daemon to display the containers that are running and as well as all the containers. It is requesting the daemon to show all the containers, whether they are running or not running, it doesn't matter. It requests to show all the containers. Now it will go and show all the containers. Now if you can see, this is the command way, Docker PS-a, where it is showing all the containers. Or else in the another way, if you go to the GUI, graphical user interface, you are having the containers and containers tab. Under the containers tab, you are having the container. Now it is showing. Okay, good. So now if I give another command, Docker images, here you can see it is displaying the images, which means if I run the command Docker images, then it will go to Docker images field and it is going to display the images. Okay. So now, for example, this is the containers field where all the containers are there, containers. And this is my images. So whatever the images that are locally present, it is going to display all the images locally. So these are all the images that are present locally. Okay, local images. Now what I will do after doing so, now I want to create an Nginx container. Okay, so to create the Nginx container, what I will do here is Docker run -itd -name web app2. This is the container name with the image Nginx. Okay, so you can say that, sir, Nginx version 1 is available inside the images repository. What I will do here is I will remove that. Docker, first of all, to remove that, we have to remove this container. So what is the container that is created with Nginx version 1 image? That is web app container. If I have to delete the Nginx image from the repository, I have to delete the containers that are created by that image. So now what is the container that is created with that image? Web app is the container. First of all, let us remove that web app container. Docker
Chaitanya,
RM.
one clarification. Chaitanya, so first we create containers, and from containers you create image, or
First image
miss.
should be there. Without image, containers will not be created.
Oh, first image will be there.
Yeah, image should be there. It is
Okay.
not image
So,
will be there. Image should be there. Without image, you cannot create any container. Later,
oh,
from that container, if you upgrade the container, like I have created a basic container, okay, which
okay.
doesn't have any utilities. You're
Uh-huh.
getting the point? Which doesn't have any
Oh,
softwares, anything. Okay. Now what I will do inside the container, I will install all the softwares. Okay, whatever the
okay.
required softwares are, I will install all the softwares. Now I want to convert that container to an image so that all the softwares will be present in the new image, right? So if I am
Okay.
having a container, now inside the container, what I did, I have installed all the softwares. Now if I convert that container as an image, now inside that image also I will get all the softwares. Are you getting the
Mm.
point? New image.
Yeah, yeah.
Now,
Okay.
this new image, if you try to create a container with this new image, what happens into that container? You will have all the softwares, no?
Oh, okay, okay, okay. So basically, okay, if we get the someone would have built an image, and
Yes.
we create a container for from that, and again build our own image.
So first you will have a base image. That is what? Whether it might be from the Ubuntu official, or you
Okay.
will have the Docker Hub. From the Ubuntu official, you will have the base image. On the top of the base image, you will install all your requirements, and then you will convert that container into an image. Okay.
Yeah.
And if you
Okay, okay.
want any new container, you can create that new container from this new image. Okay.
Okay, okay. Yeah, yeah.
So now, first of all, let me delete this web app. I'm deleting the web app container first. So to delete the web app container, the command is docker rm web app. And now what you can do, docker rmi nginx version 1. Nginx version 1. So now if you see docker images, so now we don't have the nginx image in our docker demo. Now if you see here we don't have the nginx image. So I have only Ubuntu image. Now what I will do here is I will create another container with the Nginx image. How I will create? See here, docker run hyphen itd hyphen name web app and the image name is Nginx. Okay, right now in my local repository, local image repository, I don't have the Nginx image. I don't have the Nginx image, but I have the Nginx image in the Docker Hub. I will go to Nginx. Okay, so in my account I don't have, but if you go to the general Docker Hub, let me go to the Docker Hub over here. See, Nginx image is there. Okay, so this is the what I can say official Nginx website. Here I am having the Nginx image. So it is going to pull the image from the Docker Hub. Now if you can see docker run hyphen itd hyphen name of the container, and I have given the nginx. Okay, nginx is the image which I want to pull and create the container called as web app. So which means that if you want to create a container called as web app, you need to have the image nginx in your local registry. But right now I don't have any nginx image in my local registry. So now what happens here? Docker daemon knows the path for Docker Hub. Okay, it knows the path for the Docker Hub. It will go to the Docker Hub and communicate whether Nginx image is available or not. So if you give only Nginx, if you give only the image name without any tag, like colon version 1, version 2, like that, if you don't provide any tag, automatically it is going to attach a latest tag after the image name. Try to understand. If you don't give any tag over here, if I give the tag, it will understand the tag and go and search for the image with respective to the tag. If I don't give any tag, whatever the latest image is there, it is going to pull that latest image. Now see here, what it is saying, unable to find the image, Nginx latest. Look at that. Did I give the latest tag? I did not give the latest tag, but it is attaching its own latest tag. So it is unable to find the Nginx latest locally. So now what it is doing, it is pulling from the Docker hub. So in the Docker hub, you will have the official Nginx image. Not only official Nginx image, you will have somewhere like Ubuntu images. You will have Ubuntu image, you will have the Java image, you will have Python images, like whatever your requirements are there. Depending on all your requirements, you will find all the images. Now, what is happening here? It is pulling the image from Docker Hub to the local repository. Now you are having the Nginx image over here in your local repository, and with the help of this Nginx image, it is creating a container. It is creating a container.
Oh, so it will pull the image from the Docker Hub to local, and then from that local image only it will create container.
Now, if you see Docker images, here you are having Nginx latest.
Oh, okay, okay. Yeah,
And from
it
that,
is.
it is going to create the container. Okay. So this is the Docker architecture. If you see the architecture, what happens whenever you run the command, first the command will trigger to the Docker daemon. And for example, if I want to create a container, if the image is available inside the local repository, automatically the container will be created. If that is not on the local repository, Docker daemon will search in the Docker hub, and from there it is going to pull and store the image in the local repository and create a container. Now, if you want to delete any container, then also the request will go to the Docker daemon and it will go to the containers directly and delete the container. If you want to delete the image, Docker daemon, and from the Docker daemon images repository, it is going to delete the images. If you want to delete any network, there will be another network column. It is going to delete the networks from there. So this is how the entire architecture of Docker will be looking like. Understood?
Yes.
Everyone. Is it clear?
Yes, it's clear.
Okay. Ben, Murali.
Yeah.
Am I clear with the concept?
Yes.
Okay, cool. Okay, so that's about the concept of the Docker architecture. Tomorrow, in the next session, we will be discussing about the Docker lifecycle. In this session, we have completed the Docker networking and Docker architecture. So from next session onwards, it will be 1.5 hours, like up to 8 o'clock, where we are going to cover the Docker lifecycle and as well as Docker images. Hope you understand the entire concept. We'll meet in the next session. If you have any further questions, you can ask me.
So
Yeah,
Docker
one question.
networking is not completed, na?
Sorry?
Docker networking is not completed, na? Means just overview you gave, correct?
That is only the Docker networking.
So it will get covered again, or
That's it. That is the Docker networking. So it is not an overview. You are having only bridge network adapters, how the Docker will be communicating. If you search in the Google also, you will get that only. Okay. So only one thing I have skipped here is how you can create your own. See, here it is when I create an external network adapter, I have created just with the name. If you want your own IP address also, you can give that. Okay. So you can search in the Google to provide the IP address. For example, Docker network custom side. There is a command for that. Custom IP ranges for the new networks. Whatever the new networks that you are creating, you can give a custom network. Previously, it's a default 172.18. I did not define that. Automatically, it is assigning. Docker is assigning. If you want to have your custom network, you can have the custom network also. Okay. So Here you are having the command Docker network create. Okay, so this is for the overlay. This overlay you will get in the Swarm. Okay, so where is this? Yeah, this is the new network Docker network create -- driver bridge, and you can give the subnet so that it is going to create a new subnet. So you can copy this and you can execute over here. So if you see here, what are the Docker networks that I am having? If I go to the Docker desktop. Okay, so I will show you in the Ubuntu also. Both are the same. Whatever you are giving the commands in Windows, the same you are going to provide in the Docker in the Ubuntu also. Okay, so hold on. Yeah, here you can see you are having volumes, you are having builds, you are having extensions. We can go for the extension called as network also. But as of now, if you see here, what is the Docker network? Docker network ls. Okay, so there are the same. Now what I will do, I will create a new network. How I am going to create? So Docker network create -- driver. Driver is the bridge driver, and -- subnet 172.168.0.0.0/16, and this is the name of the network which we are creating. BR0 in the sense network. So for example, I will go for new net. This is the name of the network. So new network adapter will be created. See here, new net. It is created. And what is the range we have? Docker network inspect new net. If you can see, the subnet is 172.168.0.0.0/16. Previously, we did not define the subnet, but now we have defined the subnet. If you want your containers to be created under a particular network, you can give the subnet and as well as the IP ranges. That's it. Okay.
Yeah. So here
Yeah.
we just mention CIDR block, like
Yeah.
in big
If
CIDR
you
we
want to give like this also, you can give. See here. Here you can give the IP address, IP range, everything you can define. So it will be your customized network adapter. You can create your customized network adapter. Okay. See,
Okay.
this is the command Docker network -- driver bridge driver. Subnet is this, and IP range is this, and then gateway is this. That's it. Okay.
Can you show that command again? I have doubt. Like here they have mentioned for subnet they have mentioned some CIDR. Then again for IP address they have mentioned once like CIDR. So and for
This
gateway.
is not a see. Have you read this? What is this saying? I think
I
you are
have
from the
read.
network branch. Network branch. IP range means this
In
is 172.28.0.0/16, which means /16 means you are going to get 65,000 network IPs. Okay.
correct.
My IP range means 172.28.5.0/24, which means that in this IP range only I can create the containers, which means that I can create the containers with 172.18.5.1, 5.2, 5.3, 5.4, like that. The containers will be created, and somewhere around 254 containers will be created. Why? Because the IP range that I have given here is /24. /24 means 256 IP addresses will be coming, and among those two network, one will be the network ID and the other one will be the broadcast ID. In between, whatever the IP addresses that you are having, those will be 254 usable IPs. Okay. So among those, one IP will be going for the gateway, and remaining 253 IPs will be there, which will be assigned to your containers. Is it clear now?
Yeah, clear.
Yeah. So that's a
Yeah,
yes, yes.
gateway
Go on.
IP, I mean, gateway IP that there is something, no? Yeah, gateway, yeah. Why it's you, I mean, when it is we work,
Sorry.
gateway IP when it required. I mean,
If you are comfortable in Hindi, you can speak in Hindi. I will understand. I can understand.
हाँ, गेटवे जो लिखा है वो कब यूज होता है वो चीज?
Gateway IP is the main IP. How your request will go to internet without gateway? My question is, no, my question is, you are inside your home. Okay. You want to meet your friend. You want to meet your friend who is somewhere in some another city or else somewhere in nearest neighborhood. Okay, there is another friend of you. Now, if you want to go to your friend's house, first of all, what you will do? You have to come out of the house, no?
Yes.
So how you will come out of the house? You have to open the gate and you have to come out. Without opening the gate, you cannot come out, right?
Yes.
So in the same manner, I am having some data in my container. Also, my container is requesting some data. If from where it is requesting from the internet, my container is requesting some data. Now, when the container is requesting the data from the internet, first of all, it has to leave the Docker. No, are you able to understand?
Yes. Yes.
First of all, the request has to be leave from the Docker. So if it has to leave from the Docker, there should be a gateway, right?
Yes.
So without gateway, so gateway should also have an IP address. Without the gateway is having the IP address, the request won't go further into the internet. So gateway is like an entry and exit point, which will have the IP address.
Okay. Got it.
Yeah. So that's it. Anything else?
No, it is clear with containers and images. Just this is out of the topic. Where does the pods come? I know it is too early. Pods,
Kubernetes.
oh, in Kubernetes.
Yeah.
Okay, fine. We'll discuss them. Yeah.
There is
Thanks
one
a lot.
more host network it is showing, right?
Come again?
One more, there is one more host network it was showing in the list. Can you just explain that?
Host network is nothing but your server adapter. Docker network ls. You are talking about this, right? So if I go for if config, what is this? See here, this is the host network. ENX0 is there? No, that is the host network. ENX0, what is ENX0? That is a network adapter for your server. Okay. See, first of all, where we have installed the Docker, I installed the Docker in the server. Yes. Now, if any data that should be coming into the Docker, first of all, it should reach the server, right? So if it has to reach to the server, it should have a network adapter, right? So that network adapter is the host network adapter. And from there, the data will be coming into the Docker bridge adapter, which is the gateway. And from there, it will be entering into the container. Clear? Hello? Whoever has asked the question, is it clear?
Yes.
Okay. Right then, we'll meet in the next session. So here ends my demo. From next session onwards, it will be a paid link. So just contact DURGASOFT for your link and get the link and join the sessions. Okay. So have a nice day and we'll meet in the next session. See you. Bye.
Oh, tomorrow is holiday, or you said some tomorrow or day after tomorrow is holiday, right?
Tomorrow it's a Diwali. It's a Diwali festival. So I don't know if DURGASOFT says so. Like mostly it will be a holiday. Why? Because I will be traveling to my hometown. Mostly it's a holiday. Okay.
Oh, yeah,
Yeah.
sure.
Is the
Thanks a lot, Chaitanya.
notes will be provided, or is just a running notes we need to take?
Take the running notes. Document I will provide. Don't worry about the documents. You will get each and every document in a clear picture. Okay.
Okay, cool.
Okay, wonderful. Thanks, Chaitanya. I'll
And
check with the
mostly,
DURGASOFT guys with the
yes,
next payment and other details.
that's fantastic. Mostly keep a running notes with you. It's very, very important to note down the commands. Why? Because it might be like in the document, I might skip one or two commands, but it's very important to note down. At least if you write down on your running notes, or else it might be a little bit faster, like whenever I'm discussing. But still, I will repeat the concept twice, so you can write down the running notes also. Don't worry. Okay. So have a nice day. We'll meet in the next session.